Right, so as you hopefully saw in the demo, we have now successfully improved the internal structure of the code using small incremental steps while maintaining the original program logic. So we haven't intended to change the behavior of the existing classes, we have just changed their design. And that's called refactoring, changing the design of existing code, improving the design of existing code. So here's one diagram of the refactoring process. Let's talk through it. So the idea is that in order to make a change, you refactor the code, and then you must run your tests. And if anything fails, then you fix that and re-go. And if the tests pass, then you're ready to do your next refactoring. I don't really quite like this diagram actually, partly because it doesn't show the fact that you run the tests before you make any change. You should always do that just in case something that you expect to pass doesn't pass. And also because, of course, if a test fails, you don't necessarily literally revert. You may just understand how the test fails and fix the bug. But whatever, I decided not to replace the picture. The key thing here is the idea is that the expected behavior of the code doesn't change during refactoring. Refactoring isn't about adding functionality, it's about implementing the existing functionality in a better way. Here's another diagram from the same source of the process of test-driven development. And here we do see creating a test and seeing it fail before we do anything else. Then we implement the feature and hopefully the test passes. And then once you're in a situation where you've got your new feature and the test passes, then you think, should I now do some refactoring before I add any other new behavior to my system? People sometimes wonder about how much refactoring they ought to do in the process of test-driven development, because the idea here is, you see, you're adding a tiny piece of functionality and making sure that its test passes, and then each time you're looking at, do I need to refactor the code, or does the existing code now support the current set of functionality in the best possible way? Obviously it's kind of a counsel of perfection that you refactor it in every conceivable way to make the code as good as you possibly can after every single feature addition, after every single test. And you don't have to do that, partly because there's really no such thing as perfect code. It's going to depend on what changes you have to make in future. Nevertheless, it is a good habit to think about whether you should do some refactoring each time you get a new test to pass. Even if sometimes the answer is no, there's nothing I need to do. Because quite often there will be something that you're kind of ashamed of when you think about it. Or you think, I really should improve that. And if you have a space in your development cycle to say, would now be a good time to improve some ugly piece of design that I'm a bit ashamed of, then there's a better chance that you'll actually do it. And the sooner you fix such things, the easier it is to fix, and the more benefit you get from having fixed them. So that's why the process is this way. Refactoring could be any small change that you wanted to make to your system design, but there's also a large catalogue of standard techniques, and Martin Fowler started this ball rolling in his book Refactoring. And there are a few of them. Method extraction, for example, is to say, if you have a chunk of code which maybe looks as though it would be better being a method in its own right rather than being a chunk of code within a bigger method, then you can extract it so that it is a method in its own right. You can give it a meaningful name, and that makes the code as a whole easier to read, and also it gives you a handle on testing that method independently, which can make your code more reliable, and so on and so forth. And it would be a good idea to visit that URL and have a browse around and read about the other kinds of things that you could do there. Another idea that you'll come across in the same kind of collection of ideas is the idea of bad smells in your code. And the idea of here is that you identify the need for refactoring based on a bad smell or a warning sign in your own code. And lists of those have been made as well. And there's a few of them, and a URL where you can find more. Many of them are very simple. For example, the idea that if you find that you've got a method which is too long, that's a bad smell. And what too long is can actually be quite short in object-oriented terms, so people will often say that ideally methods should not get longer than about 10 lines. And certainly once you've got a method which is 50 lines long, it's much too long. So in summary, refactoring improves the structure of code, and the way you introduce a refactoring is that you do small incremental steps, aiming not to change the expected behaviour but just to improve the design, and it should be part of your standard development process, and with experience you gradually develop a nose for code smells. You get to see which things it's really worth changing as soon as you notice them. This is discussed a little bit more in my book, How to Write Good Programs, and if you want a much more in-depth view, Clean Code by Robert Martin, which is really aimed at professional developers, but which you can read any time as well, gives a lot more detail. And Refactoring, Improving the Design of Existing Code is the original book that started the refactoring fashion, and that's essentially a catalogue of refactorings by Martin Fowler. And those are the URLs that have been mentioned on these slides.